Okay, so today we're going to start our last unit on permutations, combinations, and the binomial theorem. So to start with, we're actually going to look at the fundamental counting principle. So if you were told to figure out the total amount of toys in this example that's listed on the left here, and you knew that there is 2 colors for part 1, 3 colors for part 2, and 2 colors for part 3, you could draw a tree diagram to kind of map out all those possibilities. So I'm going to do that really quickly with you here. So part 1, I can have red or blue. Part 2, I can have white, orange, white, or black. And then part 3, we can have yellow or green. So now if you were to count kind of all the different options we have on the last row here, that would tell you the total possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 different possible toys that we can make at this toy manufacturer. However, once you start getting to some questions with bigger numbers, like what if there were 10 colors to pick from for part 1, you'd have a huge tree diagram. So that's why we can actually use the fundamental counting principle to figure out this question a lot shorter, or a lot more quickly, sorry. Okay, so I'm going to draw a space for each of my events. In space 1 is going to represent my first event, which is the first part of this toy, part 1. Space 2 will represent my second event, which in this case is part 2 of the toy. Space 3 will represent my third event, which will be part 3 of this toy. And now I'll just write the number of options for each of these events. So in part 1, I can have a red or blue toy, which means I have 2 options. In part 2, I can have an orange, white, or black toy, which means I have 3 options. In part 3, I can have a yellow or green toy, which means I have 2 options. So now I can just multiply these together. 2 times 3 is 6, times 2 is 12. So that's a whole lot quicker and easier than to draw out an entire tree diagram. All right, so our next question, a math quiz consists of 6 multiple choice questions. Each question has 4 choices, A, B, C, or D. Use the fundamental counting principle to determine how many different sets of answers there are. So I'm going to draw a space for each event. So each question would be an event. So I need 6 spaces. In the first question, I have 4 choices. I can have A, B, C, or D. In the second question, I also have 4 choices, and then so on and so forth. Okay, so if I were to multiply these 4s all together, I'd have 4 really to the power of 6, which is 4,096, which is crazy. Those are all the possible keys that you can make for this 6-question quiz. So that means if you were to write a quiz with only 6 questions and you had no idea which questions were right or wrong and you couldn't even eliminate any answer, you'd actually only have 1 out of 4,096 chance of getting all the questions right. Okay, so a fundamental counting principle involving restrictions. When solving problems involving restrictions, it is important that the restriction is dealt with first. And that'll make more sense when we actually look at some examples here. So to start with, we have a luggage lock. There's my picture with the correct 3-digit code. Each wheel rotates through digits 0 to 9. How many different 3-digit codes are possible? Okay, so we can have really any code. I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, I have 10 options for each of these. So I'm going to go 10 times 10 times 10, and that will represent all the possibilities. So I end up with 1,000 different possible codes. Supposing each digit can be used only once. So in A, you could use a digit more than once. So that's why you had 10 options for each one of those codes. In B, you can only use each digit once. So that means for my first number, I have 10 choices. But now that I've used a number, I only have 9 choices left, and then 8. So this represents if you had no repeating digits. So we end up with 720 for B. All right, let's try the next one. How many odd 4-digit numbers are there? So we're going to draw a space for each digit. Now we know our odd numbers are 1, 3, 5, 7, 9. When you have a 4-digit number, only your last digit needs to be odd. 6,241 is considered an odd number. However, only the last digit is actually odd. So our last digit has to be odd, which means it has to be 1, 3, 5, 7, or 9. So this is a restriction to this question. So I'm going to always start with the restriction. So that means I actually have 5 different numbers to pick from. Okay, our first digit can't be 0. And the reason for that is if I had a 0 here, it would no longer be a 4-digit number. It would be a 3-digit number. So I can't have a 0. However, I can have any other number from 1 to 9. So that means I have 9 options. For my second digit, it can really be any number. So I have 10 options and then 10 options. So I'm going to type 9 times 10 times 10 times 5. And I end up with 4,500 as my answer. All right, in the next question, how many odd 4-digit numbers are there that have no repeating digits? It's the exact same question, except for this time, our digits can't repeat. So we're going to draw 4 spaces out, just like we did before. Once again, our last space has to be an odd number. Okay, out of 1, 3, 5, 7, or 9, we have 5 options still. But for our first space, you can't have 0. You also have used a number since we can't repeat digits. We've already used one of the numbers. We can't have 0. So that actually means we only have 8 options to choose from. For our second digit, we can have any number. However, we've already used 2 numbers, which means we have 8 to choose from. For our third digit, we can have any number. However, we have used 3 numbers, which means we have 7 digits to choose from. So when I'm presenting this question, I always have someone in the class ask this. Well, Mrs. Ward, it says you can't have repeating digits, but you just wrote 8 twice. Remember, those 2 8s don't represent the digits 8. They represent the choices, right? So I have 8 choices here and 8 choices here. So it's not a digit that I repeated. It represents the choices for the digits in that particular spot. So I'm going to type that on my calculator. 8 times 8 times 7 times 5, and I end up with 2,240. All right, so we're going to look at this question here. In an example involving or, you will always add. So whenever you can use or, you're going to add. So the telephone numbers allocated to subscribers in a rural area consists of one of the following. The digits 345, followed by any 3 further digits. So this is option 1, 345, plus any 3 other digits. So you could have any digit from 0 to 9, and it doesn't say that you can't repeat, so then we'll assume you can repeat those digits. So then we end up with 10 times 10 times 10, which is 1,000, right? Because we're not going to actually times that to the 345. That 345 just tells me what the option begins with. Option 2 is the digit 2 followed by one of the digits from 1 to 5. So I'd have 5 choices, followed by 3 other digits. And again, there's no restriction, so they can be any digits, which means I have 10 options for all 3 of these. So altogether, I have 5,000 options. If I add those together, 1,000 plus 5,000, I end up with 6,000 total options. Okay, so that's where the addition comes in, because we either have option 1 or option 2. So we're using that or word, and when we can use that in these types of problems, we will add instead of multiplying. Okay, question 2. Consider the number of distinguishable 4-letter arrangements that can be formed from the word English, any letter in any position. So let's underline 4-letter arrangement or circle it. So in English, there's 1, 2, 3, 4, 5, 6, 7 letters that we have as options. However, we only want a 4-letter arrangement. Okay, so in my first letter, it can be any of those 7 letters, so I have 6. Because I'm arranging these letters, I can't repeat them, right? Arranging kind of means like you're grabbing those letters and putting them in specific places. So that means here I have 6 options, and then 5, and then 4. Notice how in the word English, all the letters are different. We will look at examples later in this unit on what you would do if some of those letters were the same. So we have 840 different options. Okay, in the next example, the first letter must be E. So we have E, and then we have 3 other letters. So now instead of 7 letters to choose from, we have 6 letters to choose from because we already have used the letter E. Okay, and then 5, and then 4. So on our calculator, we're going to type 6 times 5 times 4, and we end up with 120. The first and last letters must be vowels. Okay, so I'm going to write this out. So and just in case you weren't sure, in the word English, E and I are both vowels. So you have 2 possible vowels that you can use. You can start with either one. I'll start with the first one. So I have 2 vowels, and then I've used one, so I have 1. So once again, it doesn't matter if you start with the first vowel or the vowel at the end, you'll end up with the same answer, but you always want to start with the restrictions first. Okay, so now that I've done my restrictions, the 2 letters in the middle can be anything, but I've already used 2 letters, so that means I have 5 letters left to choose from, and then 4. 2 times 5 times 4 times 1 is going to end up giving me 40. So my answer here will be 40. All right, last question. There are 2 routes from Pitland to Queensville. So these are those 2 routes. I'm going to use the highlighter here. 3 routes from Queensville to St. Luke's. And 3 routes from Pitland to Rutherford. And 1 route from Rutherford to St. Luke's. How many routes are there from Pitland to St. Luke's if you pass through Queensville? So we would go from Pitland to Queensville, which we have 2 routes. And once we get to Queensville, we'd go to St. Luke's, which we have 3 routes. So we'd have 2 times 3, right? Because we're going through Pitland to Queensland, and then from Queensland to St. Luke's. So we're using the word and, so we're multiplying. So I have 2 times 3, which gives me 6. How many routes are there from Pitland to St. Luke's passing through Rutherford? So I'm going to go from Pitland to Rutherford, which gives me 3 routes. And then I'm going to go from Rutherford to St. Luke's, which gives me 1. So because I'm going from Pitland to Rutherford, and then from Rutherford to St. Luke's, I'm multiplying because I used the word and in that statement. So now I want to figure out the total amount of routes. How many routes are there from Pitland to St. Luke's? So we can either go from Pitland through Queensville to get to St. Luke's, or we can go from Pitland to Rutherford to get to St. Luke's. Because we're using that or statement again, we will add our total options. So we're going to take 6 plus 3, which gives us 9. Okay, so with this unit moving forward, when we use the word or, we're going to be adding in most scenarios, and when we use the word and, we will be multiplying in most scenarios. Okay, there's some questions that you can practice. The hardest thing about this unit is the wording, so it is beneficial to practice some of those questions to get used to the styles of wording.